सबसे पहले आता है visibility. What do you understand? What is visibility? When we talk about visibility, तो क्या आता है आपके मन में?
Maximum distance which we can see.
Isn't it? Yes. So basically, technically, transparency of the medium. Yeah, transparency of the medium, that how far at sea we can see the ships, we can see the objects, we can see anything. And यही visibility जो है, it gets good, it gets deteriorated if something is there in the atmosphere and if the atmosphere is clear. So this is what basically your visibility is, the transparency of atmosphere, and defined as the maximum distance at which an object can clearly be seen in normal daylight. So how this visibility changes? Visibility we call maybe due to the presence in the air of visible moisture in the form of liquid, water droplets, water vapor which is invisible, or solid particles such as dust, smoke or sea salt. Very common nowadays. You will be seeing अंधेरी चल रही है, dust storm आ गया. At sea also sometime passing Red Sea, you see this sand flying, and due to the sandstorm, and you see your visibility getting affected. But basically if you see, so these are the various things where transparency of the medium can be affected. Now good visibility if we see is favored by air temperatures which are below that of underlying surface and by strong winds. ये जो सारी visibility का जो main reason है, what we call is the fog. और इसकी भी terminology थोड़ी सी अलग है. Now when the horizontal visibility lies between 1000 to 2000 meters, the terms mist, haze are used. The former only when the atmospheric obscurity is due to the presence of moisture, and the later when due to solid particles. Now the term fog is applied when the visibility irrespective of the cause is below 1000 meters, half a nautical mile. We always say yes, we are going into the restricted visibility. And then you say poor visibility means zero, cannot see. Difference again in your restricted visibility and poor visibility. And you may have experienced sometime a very thick fog where you can't see even the forward railings just in front forward of the bridge. Forget about seeing the mast. So forward mast तो दिखता ही नहीं है. Even कई बार forward के आगे railing है जो आपके लगे हुए, वो भी नहीं दिखता. Visibility which is impaired but is more than 1000 meters is described as mist, and when caused by water droplets, and when the relative humidity more than 95%, when caused by smoke or dust particle, it is described as haze. Very common term we write hazy, horizon is very hazy. So ये जो haziness और ये जो mist है, this is basically if you call the causes of range from forest fires, smoke from industrial areas, or dust, sandstorm which may be experienced to seaward of desert regions such as of West African coast or of Arabian coast when seasonal winds blow off the land. तो ये तो है कि yes, आपकी जो haziness है, it is due to the these factors which are causing. So sandstorms may extend up to 100 miles out to sea, constitute a serious problem for the mariner. How many of you have experienced very common Red Sea? एक तो visibility खराब, ऊपर से सारा ship जो है उस पे मट्टी जैसी आ जाती है, फ्रंट जितने white structure है सारा लाल हो जाता है, to wash. तो हमारे लिए तो again extra work comes. So now comes the formation of fog. Basically fog हमने देखा है कि yes, it is affecting my visibility. How these fogs are formed? Methods of formation of fogs. So sometimes the fog, certain fogs they form only at sea. Certain form of fogs it forms only on land. So we are more concerned about sea, that how the visibility gets affected, and I should be able to know. Now अगर आपको थोड़ा सा ये पता है, तो you can even predict what is the seawater temperature, what is the air temperature. Now you know how the formation of fog takes place, so you can be very well prepared. And there are certain areas over this planet where you have permanent fog, or where the conditions are such that you will experience a thick fog. वो भी हम देखते हैं. Now first of all, the formation of fog, if you see, the fog is formed by cooling of a large volume of air below its dew point. Again, back to same basics. The air is cooled, so as the air rises, so air cooling can be done many ways. If it is climbing up the mountain, as the air rises, so basic thing, when the air starts rising, it expands and it starts losing its temperature, it starts becoming cold. And जैसे उसका temperature नीचे आएगा, the humidity starts increasing. We have seen the relative humidity is inversely proportional to temperature. Air saturate होनी शुरू हो जाएगी. So the moment air is 100% saturated, and then if it is cooled below that, इसके अंदर जितना water vapor है, it condenses into water droplets, so resulting in condensation, a process similar to that of cloud formation taking place at or near the sea or ground surface. Now in certain circumstances, it may also be caused by the evaporation of water vapor into the air. So formation of fog जो है, in a very simple terms, the necessary cooling referred to above, the cooling of the air is basically by proximity to cold land or sea, and that's how the air can get cooled, and some turbulent mixing of the air. इन्हीं सारी चीज़ों को देखते हुए we have the types of fog. So what are the various types? We have advection or sea fog, what we call, frontal fog, radiation, Arctic sea smoke, or orographic sea fog, what you call, isn't it? So this is basically the few forms of fog. So first we see advection fog, which is most commonly what we call the sea fog. This is the most widespread type likely to be encountered at sea, and is caused by, how it is caused, by relatively warm air being cooled by flowing over a cooler sea surface. Now if your sea surface is cool and the air is warm, you will find this fog formation. How? The latter will be below the dew point of the air, isn't it? After sea surface it is cooler, so now it is below the dew point of the air which is blowing up, which is pretty warmer air. So that's why if the dew point is below, and normally the wind speed will be between 4 to 16 knots, about force 2 to 4, and you find this fog taking place. There are only certain localities where such conditions are relatively prevalent. So ये कौन सी है? One of this is off the Grand Banks of Newfoundland. वहाँ पे क्यों ऐसा होता है कि वहाँ पे जो cold Labrador current, which is a very cold current coming from north, causes a decrease in sea temperature. Sea surface आपका cold current आ रहा है तो sea surface को ठंडा कर देगा. Moist southerly air stream flowing over this is cooled below its dew point to form advection or sea fog. This is a very common thing when you go off the Grand Banks of Newfoundland. So we are always day one say, yeah, we are going to pass this. First of all, thick fog. चलो आपके पास you got little better radars, GPS, everything is there. Previously हमारे radars भी जो थे, they were not so good. 3 miles, 6 miles के बाद आएगा नहीं आएगा, nobody knows. Plus position. Today with the advent of this technology, GPS, you know every second where your ship is, how far you are from the coast, how far you are from any island. That is not the problem. So only traffic, you have to only see the traffic. उसके लिए आपके पास आजकल sophisticated radars है, आर पार है. You can all see that. So fog में सबसे पहली चीज़ ये आती है कि yes, these areas, that's why these areas are considered dangerous, because there's a possibility of it's not being traced. Current causes a decrease in sea temperature. So ये जो cold Labrador current है, this will definitely decrease the seawater temperature, and the warm moisture blowing over this cold sea surface will definitely get cooled below its dew point, and condensation will take place, and finally you find the thick fog taking place. So southerly air stream flowing this, it causes, and this type of fog is what we call the advection or the sea fog, because it is forming mostly over the sea. Another place where it is forming, your English Channel, unaffected by advection fog. Southwesterly winds reach the British Isles from Azores in the spring and early summer. So English Channel also are the again deadly places. अभी भी है कि yes, when you are a watch keeping officer, you always become alert. You know these areas. आजकल of course weather report भी है. I have knowledge that English Channel, अगर हम spring early summer में जाएंगे, there is a possibility of fog, so you are pre-prepared. Extra lookout या आपको lookout रखनी है, या keep a watch, because today the traffic is also increased. ये तो है नहीं कि पहले टाइम की तरह few ships were there. Now everywhere there's a lot of ships there. So इसके लिए इन areas की knowledge of Grand Banks of Newfoundland, English Channel, of Japan. Japan में भी क्या होता है, off the east coast of Japan where warm moist westerlies blowing over warm Kuroshio cross over to Oyoshu, which is a cold water. So there again you see this advection fog forming there. Why? Because of this Kuroshio. ये 3 जगह है जहाँ पे advection fog आपको very commonly आपको मिल जाएगा. So it is possible to estimate the likelihood of the formation of fog from observations of air temperature. ये भी हम कर सकते हैं. आप log book में भरते हो sea water temperature, air temperature, direction, other weather signs, plus a knowledge of sea temperature to be expected on the course ahead, and definitely even predict when this advection fog I will encounter. So ocean routing charts अगर आप देखिए, most of you must have seen, भी important है ocean routing charts, उसके ऊपर क्या क्या information है. So there also if you see thick fog areas are predicted there, so they are mentioned, and उनके अंदर आपको what you call this routing charts पे mean sea water temperature is given, dew point temperatures are given, percentage frequency of fog, visibility less than half a mile, those areas are also marked. So you see कितनी information है. Only thing is I should know which information to get from where. Even अगर मैं उसको भी खोलता हूँ during the passage planning or when we are moving. So पहले paper chart होते थे. Second officer जो passage planning बनाता था, used to mark there कि thick fog is expected, because he used to go through these books, these charts, and then highlight for the duty officer, for anybody कि these areas fog will be present. So please be careful. The idea is I should not be taken surprise. Suddenly हम चल रहे हैं and you find there is a thick fog. Percentage frequency of low visibility, that is also given in your routine charts. Mean air temperatures, barometric pressures. तो इन सब से अगर आप देखिए तो you can even predict, अगर आप इसको plot करते हैं local time पे, the dew point temperature and the sea temperature को अगर आप करते हो, wherever these two temperatures are meeting, that this is the place 1400 hours, that there is a chances of sea fog forming. जैसे ही sea water temperature आया और ये dew point का curve जहाँ पे मिलेंगे वहाँ पे fog will be there. ये तो रहा आपका advection fog. How this fog is forming, mostly you encounter at sea is the advection fog, and the areas you have seen where this fog is very prevalent. So radiation fog forms over land mostly frequently during autumn and winter over low-lying land, especially if it is damp and marshy and in valleys on quiet nights. Q with clear skies. Why this radiation fog and how it forms? Under these conditions the land loses heat by radiation. इसीलिए से radiation fog कहते हैं कि night time जब आपकी, we have studied that there is no incoming radiation from the sun, so the land starts losing heat, it starts becoming cold. So naturally जो air है that also in contact with this land also starts becoming cool because of the radiation of the heat. So possibly too, and जैसे ये air ठंडी होगी, so it's possible that if it gets cooler the dew point, condensation will take place. There is a gentle breeze blowing up to say 5 knots. This will cause turbulent mixing. Mixing hogi, so only close to the surface, and condensation in the form of fog will take place. So radiation fog is only possible on the land. Why? Because of the land during the evening, night time losing heat and becoming cold. So the air also in contact with the land also becomes cold, and if it becomes cold below its dew point, condensation. Stronger wind will cause the cooling to be diffused through a greater depth of air and the dew point will not be reached. So इसके लिए gentle breeze चाहिए, stronger breeze होगी तब भी fog formation जो है not possible. Since cold air is heavier than warm air, it will tend to drain down into the valleys. So naturally अगर आप देखिए down in the valleys आपका total complete एक blanket of fog will be seen to you. Although it is never actually forms over the sea, it may drift from land for several miles but seldom extends for more than 10 miles offshore. आपकी sea coast है to the high mountains, so there is a possibility this can drift down, but again it is restricted only on the coastal areas. But coastal में भी of course हमें navigation तो करनी है, ships have to go to the port. तो यहाँ पे भी problem रहती है कि yes, when you approaching a port, fog और भी dangerous हो जाता है. So radiation fog will most dense around sunrise and normally disperses fairly rapidly as the land warms up. So the radiation fog, I think very common, that you have seen how the land gets heated and how the land gets cooled due to the solar energy. So night time there is no solar incoming radiation is there. You see this land becomes cooler and the radiation fog forms. This is what basically night time is taking place. Cooling at night time, and this cold air again rising and then getting cooled below the dew point, converting all this water vapor into the water droplets. Conditions favorable for radiation fog. क्या क्या हमें होना चाहिए? Large moisture content in the lower layers of air, little or no cloud at night, clear skies, then only this of heat from the land will take place. अगर cloud cover होगा तो फिर तो land ठंडी भी नहीं होगी. Light breeze at the surface and cold wet surface of land. So when all these conditions are met, all these conditions are there, so you see this land fog or the radiation fog forming. ये तो आपका हो गया radiation. अब sea में और क्या होता है? Arctic sea smoke क्या है? This is a type of fog occurring close to the sea surface. Air is dry and cold, probably at least 9 degrees centigrade below the sea surface temperature. अब ये क्या है? Now the air is very cold. and rapid evaporation takes place from the relatively warm sea surface. So पहले तो था कि cold sea surface and relatively warm air was blowing over this and we were seeing this advection fog forming. यहाँ पे उल्टा हो रहा है कि आपकी जो sea surface है that is relatively warm as compared to the wind or the air which is blowing over it. So relatively warm sea surface into the colder air and condensation takes place giving effect of steam or smoke rising from the sea. अब आपका जो sea है that is relatively warm and the air above it is pretty cool, so it is 8 to 9 degrees below the sea surface temperature. This Arctic, that's why it's called Arctic sea smoke, because it takes place on the very higher latitude near the Arctic areas, because the wind is very cold there. It looks like basically like a streams smoke, like a smoke you can see. That's why called a Arctic sea smoke. It literally appears that the sea is smoking like this. That's the smoke rising from the sea. It is because of warm sea surface. This air which is just in touch with this warm sea surface, it is getting cooled because of the adjacent very cold air in touch with the sea surface. Now it's most common in Arctic and Antarctic waters and in the Baltic, but it can also occur off eastern coasts of continents in winter, for example off Newfoundland or inland seas and lakes. This is one of the fog which may also be associated with strong winds, since it requires a continual supply of cold air. So Arctic sea smoke, if you go to higher latitudes, so you may come across, because it's a very cold breeze, very common, that is blowing over a relatively warm sea surface. अभी अगर आप fog formation देखिए, yes, it is basically controlled, or formation takes place between the difference in temperature over where the air is blowing. So if the air is sea surface, if the sea surface is warm and the air is cold, then you have this Arctic sea smoke. And if the sea surface is again cold and the warm air is blowing, then you have the advection fog. Radiation you have seen because of the land. Now the land is getting cooled and then you find that fog taking place. So these are the basic, very basic few reasons that you see that fogs forming, and we can definitely see. Now another is a orographic fog or hill fog, what we call. Now हमने cloud formation भी देखी थी, orographic method of cloud formation. Same thing is here. When a wind comes against a mountain range and begins to climb over it, so it progressively cools adiabatically. So that we have seen without any heat getting transferred. So that's the adiabatic process. And this is rising or going up the mountain, it progressively gets cooled, and after the dew point is reached, any further cooling causes the excess moisture to condense into water droplets, forming a hill fog or orographic fog. So basically oro means mountain, so you can simply that hill fog formation is also possible. Hilly areas very common now in this rainy season. If you go towards the areas, so you will find that totally complete blanket of this fog will be seen, because as the air starts rising from the lower lying areas, जैसे ही ऊपर जाती है, it gets cooled, cooling below the dew point takes place. So थोड़ी सी precautions हैं आपकी sound signals in the fog, कि आपने fog देख लिया, fog formation you have understood. Now the possibility कि यार इसका effect क्या होगा. One we have seen that yes, visibility is affected, I cannot see, so we have to be very careful. We use the radars, we keep extra lookouts and all that. And also you see when you also give the sound signal. Now sound signals in fog, the very conditions which create fog may also cause motions in both direction from which another ship's fog signal appears to come and in its strength. इसके लिए अगर आपका fog है तो of course we see the fogs, and very common you see due to this thick fog it is very difficult to make out कि अरे आप ship का fog signal कौन सी direction से आ रहा है. So it is very misleading. So this is also one of the effects because of the atmosphere जिसके अंदर आपने sound ने travel करना है. So sound also gets affected of these different conditions in the atmosphere. Watchkeeper therefore exercise considerable caution when attempting to estimate either distance from another sound source or its direction. So ये भी आपके लिए precaution है. Yes, when you are keeping a watch, when you are watching, when you are seeing these things, so just see that आपकी ये knowledge जो है, ये जो sound signal है, the sound also will be affected. So you try some restraint before you make a judgment कि ऐसा भी हो सकता है, isn't it? So this is also possible. Same thing, use of radar in fog. Use of radar in fog also you have seen. Meteorological factors may affect normal expected range of radar. तो अभी आपने जिन्होंने radar course किए हैं या use किया है radar, of course you see this, the radar range also gets affected. So if humidity decreases with height, super refraction is expected, resulting in considerable increase in the radar range. This is again due to the humidity. Now if the humidity decreases with the height, then this thing takes place. On the other hand, if the humidity increases with the height, subrefraction takes place, may be expected with a consequent decrease in range. So ये fog के जो हैं effects वो भी हमें थोड़े से मान में रखने हैं, mind में रखने हैं when we are basically keeping a watch. यार fog तो formation हो गई, where all will get the fog, you are prepared. So at the same time these things are also possible, so we use caution. Thing is to use caution, be extra cautious that these things are possible, to be on the safer side. So whatever all methods available we use that. So ये तो था आपका fog, various types of fog and various types of fog formation. ठीक है, I hope understood. Any doubts? इस पे क्वेश्चन भी सिंपल आते हैं. What are the various types of fogs and how straightway भी लिख सकते हैं. Describe advection fog forms or which all areas this fog is normally encountered. So I don't think so कि इसके लिए आपको ज़्यादा effort करना पड़ेगा. Of course it's there in the book also. Slightly I have deviated also certain extra things, that use of this radar, use of sound signals, how they get affected, formation of the fog, how we can go about it. ठीक है, चलें next topic पे चलें. Any questions from this? Yeah, चलो good. So next हमारा था कि what we see the general circulation of your winds. We have studied what is wind, how it forms, and हमने wind का काफ़ी structure भी पढ़ लिया है from high pressure to low pressure. अब हम इसी के साथ देखते हैं आपकी जो general circulation है. Now you know on this planet how this general circulation basically takes place. So it gives you a fair amount of idea where you are sailing and what type of winds you can expect and why these winds are basically working on these areas. Now general circulation of winds, if you see, there were no seas, I mean there were no land. If there was only seas, फिर तो ये wind pattern जो है बिल्कुल steady होना था. All over the place there would have been the wind pattern which is like this. Near the equator, trade winds, westerlies. But अब यहाँ पे क्या है कि yes, on this planet we have huge land masses. Land mass भी बीच में आ गया, seas भी हैं, and the wind pattern जो है थोड़ा सा disturb हो जाता है. There was only seas, and of course you would have faced all the time same type of wind direction. To these land masses ये थोड़ा सा effect है. So let's see हमारी जो general circulation है, how this general circulation takes place. So winds are comparatively uniform in longitudinal belts around the world. Some local exceptions are there. Otherwise, basically, you see near the equator what we call the Doldrums, mainly light winds. North of this Doldrums or ITCZ, what we call 1 degree to 30 degree, lies the belt of northeasterly trade winds. So basically, if you see now, this is the ITCZ or Doldrums, and from 10 to 30 degree, you see this area is basically known as the trade wind zone. So these are the trade winds blow from here. And then again, this yellow portion, you see the variables 30 to 40 degree, and then 40 to 60, 65 degree, you have a strong westerlies zone. So here the winds are in a very strong westerly direction, they blow. And of course, above this 90, you have this polar easterlies where shipping is less. So this polar easterlies, less information. Basically, the direction here is the what we call the easterly, and this is the general circulation you see. Wider belt of westerlies 40 to 63 and 63 to 65, the local areas of variable wind. And then of course further north you have northeasterly or the polar easterlies. So in the southern hemisphere, similar sequence of latitude belts. So आपकी general circulation जो है, it basically on the surface of earth it is like this, that in the middle near the equator you have 5 degrees up to 10 degrees you have what we call the Doldrums, ITCZ, intertropical convergence zone, and then up to 30 degree you have trade wind zones. So here the direction of the wind is basically northeasterly. So हम देखेंगे how this thing takes place, how these trade winds form, इनकी formation कैसे होती है. And then further north you have how these westerlies form. So ये भी, so this is the basic general circulation of the winds on the surface of earth. But individual places जहाँ पे आपके लैंड मासेस आ गए वहाँ पे ये विंड पैटर्न जो है चेंज हो जाता है. वो भी हम देखेंगे. वो भी है कि yes, when this wind pattern changes then we start calling them by different name like monsoons. Areas तो वही हैं, latitudes वही हैं, but now the wind direction has changed, wind pattern has changed due to the land masses. So आपकी winds के जो नाम है वो भी change हो जाते हैं. So let's see first of all what is this doldrums. तो अब ये चीज़ भी है, इसके ऊपर भी आपको रिटर्न में क्वेश्चन आ जाते हैं. राइट शॉर्ट नोट्स ऑन डोल्ड्रम्स, साउथ वेस्टर्ली मानसून, नॉर्थ ईस्टर्ली मानसून्स ऑफ अरेबियन सी. सो ये छोटे छोटे टॉपिक्स जो हैं, नाउ इट्स बेसिकली लाइक अ जनरल नॉलेज, easily can be answered. Now what is this doldrum or ITCZ? It's a zone of light variable winds associated with rain and thunderstorms. So I don't know how many of you have passed through the equator. If you see this equator, many times you see a very good weather, and suddenly next while you pass you see lot of rain, thunderstorms taking place. So that's why इसको doldrum कहते हैं, means uncertain weather, and it occupy a very narrow belt between equator to 12 degrees and varies with the longitude. ये जो belt है ये keeps on varying. ये नहीं कि fix है कि 0 to 10 or 12 degrees. Now this varies because of the altitude, sun's declination. Sun starts moving from north to south. तो इसकी जो belts है, doldrums और ITCZ की belt also keeps on changing from the season to season. Sometimes they go slightly up, sometimes ये belt जो है 10 degree से कम हो जाती है, sometimes it goes up to 15-20 degrees. So zone is dreaded by sailing vessels for risk of becalmed. If there is no wind, sailing vessel तो move नहीं कर सकते. तो इसके लिए इस areas में you find the sailing vessels सारा weather study करके तभी चलते हैं. So trade wind system of northern and the southern hemisphere. This area is the area where trade wind system of both the hemispheres basically meet. अभी हमने diagram में भी देखा है. Now if you see here the wind is blowing in northeasterly and here the wind is blowing in southeasterly. So basically this is the meeting place of trade winds of both the hemispheres. Because of prolonged heating over the equatorial oceans, some of the air finally ascends vertically. So ये भी हो जाता है. So same thing is ITCZ. This is the same name to doldrums, intertropical convergence zone. Same as doldrums, meeting place of trade winds of northern and southern hemisphere. It's called convergence zone for the winds, tropical zones की जो winds हैं. So before that it used to be called intertropical front. Meteorologists realized no, the name was changed because of the vague and variable character of the accompanying weather. यार ये frontal, it's not a tropical front, it is basically like a tropical convergence zone of both the trade winds. Northern boundary of zone will be marked by rain, storms, squalls, thunderstorms, and it is a southern boundary. Mean position keeps shifting. अगर आप इसकी position देखिए तो अगर आपको you see in the month of January this is close to equator, then comes here, so it always remains in January it is between 0 to 10 degree. But if you see in July the sun is more on the northern hemisphere, so this IT doldrum area they shift like this. So this becomes your ITCZ, whole area shifts like this. Now this is due to the sun's altitude. ये तो simple आ गया. This is what basically doldrums or ITCZ the meeting place. अब ये जो trade winds हैं, now how these trade winds form and why they are called trade winds. On northern hemisphere, if you see, now equator all the time keeps getting warmed up. The sun is all the time shining on the equator. This warm air around the equator rises and flows northward toward the pole. So ये भी है कि जैसे ही आपकी wind जो है, sea surface हो चाहे land surface हो, when they start getting heated up, the air starts rising. So as the air moves away from the equator, the Carol's effect deflects it towards the right. ये भी हमने पढ़ा. So as this air is getting deflected towards the right, and then it is rising also. Rising say means it will get cooled. So part of this air which gets cooled, so it starts descending back near 30 degrees. So up to 30 degrees it goes, and then it is become enough cool. It has no rising capacity, so it starts descending. It starts coming down. So जैसे ये वापस it starts coming down. That means now the winds are coming from north, blowing towards the equator. Then again Carol's effect जो है इसको वापस deflect करेगा. So this descending air blows from northeast to southwest back towards the equator. Why? Because अब ये north से आ रही थी, now it is going to get deflected towards right. तो इसकी direction almost northeast हो जाती है. So this is the air which is basically becoming cool after rising and then it descends back. Similar wind pattern occurs in the southern hemisphere. So these winds blow from southeast towards the northwest and descend near 30 degrees. So same way अगर आप देखिए तो ये northern hemisphere की जो trade and southern की pattern is same. Certain parts of the wind, now these prevailing winds known as the trade winds meet at ITCZ between 5 north and 5 south. Remaining air जो है कि ये नहीं कि सारी है, हो सकता है certain air still keeps rising because we have seen the enough thermals are there to become enough cool to come down. So the air that does not descend at 30 degree north or south, it continues towards the poles and is again known as westerly. अब ये भी north को जा रही है, it will also get deflected towards the right. The Carolus force. तो जैसे ये deflect होगी right को तो इसकी direction क्या बन जाएगी? Almost से south westerly. तो north से so slowly इसकी direction भी westerly बननी शुरू हो जाती. So the trade winds are so named. Why इनका नाम क्यों पड़ा कि trade winds are named? Because the ships historically taken advantage of them to aid their journeys between Europe and America. अब सबको पता था कि ये trade wind जो हैं they are blowing. Olden time में these ships they just used to sail along one latitude. Topics में आगे जहाँ पे आपकी trade winds हैं से 30 और less than 30 degree latitude पे so they know the trade winds जो northeast से continuously they will keep on blowing from northeast so they will take them to the west and similarly that's why वहाँ उस वक्त तो ये steel ships या steam ships were not there so ships which were used for trading was basically your sailing ships so जिनको strong winds चाहिए थी भारत के बंदों की you can imagine the knowledge meteorology की knowledge was very strong so they knew इसी जगह कौन सी winds prevail कर रही हैं so these winds which are basically rising from equator and then ending back at 30 degree and then again due to Carolus force becoming northeasterly so they were named also trade winds because the trade was taking place with these winds. Trade winds are prominent all over the major seas areas both in summers and winters as northeasterly in northern hemisphere and southeasterly in hemisphere. Except उन्हीं latitudes पे if you come to Arabian Sea, Bay of Bengal, China Sea आपका जो wind regime है that is dominated by monsoons. Latitudes ऐसे हैं होना तो northeasterly basically winds तो northeasterly हैं इनकी direction जो है वो change हो जाती है. Why? Because of the land masses. There is a huge Asian continent is there के करके अब इनकी जो इसलिए नाम भी इनका थोड़ा सा चेंज हो गया monsoons. They blow more or less constantly throughout the year about latitude 30 equator. Trade winds they tend to shift northward and southward following the sun and keeps on moving from north to south. इसीलिए ये trade winds का भी जो shift है this is also keeps on taking as per the sun. The movement is small in southern hemisphere but in northern hemisphere it is 8 to 10 degrees of latitude in Atlantic and Pacific. You can imagine this whole pattern, whole this zone of trade winds also keep shifting 8 to 10 degrees in the northern hemisphere. In Atlantic mean speed इनकी है the very good wind 13 to 15 knots, not high speed winds and that's why everyone prefers to sail in the tropical areas. Higher latitudes पे जाएंगे तब भी weather खराब है. Strong westerlies, gale force, lot of depressions. But in these latitudes up to 30 degree trade winds if you are going from east to west favorable winds. Otherwise also they don't disturb the sea also because their force is only very less 13 to 15 knots. Now summary formation of trade winds. Air is heated risen in the ITCZ as a result of sun heating in low latitude therefore low pressure in ITCZ. So this rising air cooled and sink at latitude of 30 degree high pressure in the horse latitude. So above this what we call they were known as the horse latitudes. And surface air from the horse latitude that is from 30 degree north it moves towards equator due to the pressure gradient. अब आपका equator पे due to this rising air there is a low pressure created. So that's why the winds from 30 degree definitely blow down towards due to the pressure gradient because there is a low pressure near the equator. ये circulation है. As a result this force the wind deflected and resulted to northeast wind in the northern hemisphere and southeast in the southern hemisphere. So this is how basically आपकी जो formation of trade wind takes place. So this wind blows towards equator in direction northeast to east northeast to east due to the reducing effect of Carolus force. Arabian, Bengal, China Sea monsoon suppress this trade wind. So यहाँ पे monsoons are strong. The monsoon is a basically Arabic word means seasonal. Monsoon means seasonal wind. Seasonal winds अभी आपने देखा है, as we are waiting, southwest monsoon is going to come. How strong these winds blow, so they suppress this wind का जो सिस्टम है उसको ये सप्रेस कर देता है. In summer you see northeast trade wind suppresses by southwest monsoon wind direction. In this region is southwest instead of northeast. तो ये northeast trade, but in summer आपकी इन एरियाज में बे ऑफ बंगाल, अरेबियन सी, साउथ चाइना सी, you find the wind direction instead of northeast it is becoming southwest because of the strange or this landmass heating. Winter northeast monsoon reinforces the northeast trade wind giving gale force as it is. In winter अगर आप देखिए इन एरियाज में नेचुरल विंड डायरेक्शन इज ऑल्सो नॉर्थ ईस्टर्ली ट्रेड विंड्स. आपकी जो मानसून फॉर्मेशन है, लो प्रेशर इज गेटिंग क्रिएटेड इन विंटर्स in somewhere different place, so you find these winds blowing in the northeast direction towards the equator or down in the Arabian Sea, Bay of Bengal, and getting again what we call reinforcement with the northeast trades. And in China Sea, that's why you see east and southwest both the monsoons they create havoc. अब इनसे ऊपर अगर आप देखिए 30 डिग्री से ऊपर ट्रेड विंड्स के जोन से ऊपर you have the variables. So variable means the wind is variable 30 to 40 में. Over the areas covered by oceanic anticyclones between trade and westerlies, further towards the pole there exists a light and variable winds which are known as variables. So 30 to 40 wind direction is always uncertain. Weather is fair with small amounts of cloud and rain. Westerlies, अब आप westerlies पे आगे, on the polar side of oceanic anticyclone lies zone where the wind direction become predominantly west. This is above 43. Like trades, these winds known as westerly far apart from the permanent. So they keep on changing because lot of depressions, lot of gale force winds are again experienced there. So continual passage of depressions from west to east cause these winds to vary. So वहाँ पे ये जो westerlies हैं above 40, they are not consistent as much your northeasterly trades are. Gales frequent in the westerly zone above 40 degree. That's why अगर आपने सेलिंग की है हायर लैटिट्यूड्स में, वी आर ऑलवेज स्केयर्ड ऑफ द बैड वेदर, स्पेशली इन विंटर. सो दिस वेदर चेंजेस रैपिडली एंड फाइन वेदर इज सेल्डम prolonged. Gales are so frequent in southern hemisphere that zone south to 40 degrees south is basically named as roaring 40s. Roaring 40s because if you see this area south, the wind actually makes a very roaring noise. Very strong wind south of 40 south. If you go in the southern hemisphere in the winter especially, these winds make really a very frightening sort of noise. That's why it's called roaring 40s. And in northern hemisphere fog is common, western parts of the ocean. So ये तो आपका wind pattern up to the westerlies. Polar easterlies not much concern because there is not much of the navigation. So seasonal winds and monsoons. अब ये भी है कि इस पे भी क्वेश्चन आ जाता है कि राइट monsoons तो हमारे कंट्री को ज़्यादा इफेक्ट करती है. So we should know. Anybody any idea how these monsoons form? क्या idea आपको monsoon के बारे में? Okay, we talk about southwest monsoon only. We I think almost going to touch Kerala maybe today or tomorrow. These monsoons form. No idea? किसी को भी नहीं idea? ऐसा तो नहीं हो सकता है. थोड़ा तो idea होगा. Monsoon तो आजकल स्कूल लेवल में पढ़ते हैं. नहीं, how these monsoons, southwest monsoon forms, कैसे form होती है? Brief idea. I am not saying exactly कैसे, but आपके मन में क्या आता है?
When the heat variation between the ocean and land masses.
ठीक है. अब देखिए समर से अभी आपकी समर चल रही, क्या हो रहा है समर में? क्या हो रहा है? लैंड इज गेटिंग हीटेड अप, इजंट इट? वी ऑल फील द हीट. अभी लैंड गर्म होगी तो आपने बेसिक पढ़ा है कि लैंड गर्म होगी तो एयर ऑल्सो एडजेसेंट टू दिस लैंड ऑल्सो स्टार्ट्स गेटिंग हीटेड अप, इजंट इट? अब जितना आपने देखा वो कहते नहीं यार अभी तो लैंड अच्छी गर्म नहीं हुई, बिकॉज जितना ज़्यादा 48-50 डिग्री टेम्परेचर जाएगा then this land gets heated up and इसका रिजल्ट क्या होता है? अभी हमने जैसे इक्वेटर पढ़ा है, सेम थिंग हियर कि स्पेशली इन द इंडिया, इफ़ यू सी नॉर्थ वेस्ट पार्ट ऑफ इंडिया जहाँ पे आपका डेजर्ट है, सो द लो प्रेशर बेसिकली द सेंटर ऑफ लो प्रेशर गेट्स सिचुएटेड हियर इन नॉर्थ वेस्ट पार्ट ऑफ द इंडिया. नाउ यू कैन इमेजिन इतनी हीट है, द लैंड हैज गॉट सो मच हीट एंड द एयर ऑल्सो हैज रिजन, एंड जब एयर स्टार्ट्स राइजिंग तो नेचुरली जो साइड की एयर्स हैं फ्रॉम द हाई प्रेशर दे स्टार्ट ब्लोइंग. अब आपने देख लिया यहाँ पे लो प्रेशर सेंटर हो गया बिकॉज ऑफ द हीटिंग ऑफ द लैंड मास. ये जो लो प्रेशर क्रिएट हुआ है, व्हाट इट विल रिजल्ट द विंड फ्रॉम द अदर एरियाज फ्रॉम हाई प्रेशर स्टार्ट्स ब्लोइंग टुवर्ड दिस साइड. नाउ साउथ वेस्ट मानसून का सिंपल है कि आपकी जो सदर्न हेमिस्फीयर की जो ट्रेड विंड्स हैं, सदर्न हेमिस्फीयर की जो ट्रेड विंड्स हैं, उनकी डायरेक्शन क्या है? व्हाट इज द डायरेक्शन ऑफ दिस साउथ वेस्ट, आई मीन दिस ट्रेड विंड्स ऑफ सदर्न हेमिस्फीयर? दिस इज बेसिकली इन समर्स इनकी डायरेक्शन साउथ ईस्टर्ली है, इजंट इट? ये जो ट्रेड विंड्स हैं नॉर्दर्न हेमिस्फीयर में तो नॉर्थ ईस्टर्ली ट्रेड है. अब नॉर्मल कंडीशन में इन सदर्न हेमिस्फीयर दिस साउथ ईस्ट ट्रेड इज ब्लोइंग, मीन्स दे आर कमिंग फ्रॉम साउथ ईस्ट. अब आपका यहाँ पे लो प्रेशर सेंटर हो गया. दिस इज आपका इंडिया, सो नॉर्थ वेस्ट ऑफ इंडिया. दिस इज द लो प्रेशर 994. दिस लो प्रेशर हैज़ बिन क्रिएटेड हेयर. तो इसके लिए आपको यहाँ पे बहुत ज़्यादा स्टॉर्म आंधियाँ भी चलेंगी बिकॉज ऑफ द लो प्रेशर. तो यहाँ पे तो डस्ट है, सैंड है, वो सारी भी ब्लो होगी. एट द सेम टाइम यहाँ पे लो प्रेशर से ये जो विंड्स हैं सदर्न हेमिस्फीयर की विंड्स, दे स्टार्ट ब्लोइंग टुवर्ड्स दिस लो. सो इवन अफ्रीका कॉन्टिनेंट है, अफ्रीका में भी यही चीज़, वहाँ पे भी डेजर्ट है, तो वहाँ पे भी लो सेंटर क्रिएट हो जाता है, वहाँ पे भी लो प्रेशर है. तो ये सारी की सारी जो साउथ ईस्ट ट्रेड विंड्स हैं दे स्टार्ट ब्लोइंग टुवर्ड्स दिस लो. अब जैसे ये इक्वेटर क्रॉस करती है, बीच में इक्वेटर है, जैसे ये इक्वेटर क्रॉस करेगी नाउ इनकी जो डायरेक्शन है वो स्टार्ट चेंजिंग. इक्वेटर को जैसे इसने क्रॉस किया इट स्टार्ट्स बिकमिंग नदरली. कैरोलिस फोर्स जो है नदर्न हेमिस्फीयर में दे डिफ्लेक्ट द विंड टू राइट, इजंट इट? ये भी हमने पढ़ लिया. सो जैसे ये साउथ ईस्टर्ली इक्वेटर टच करती है फर्स्ट इट स्टार्ट्स बिकमिंग, because it is heading towards this low pressure to fill up this low pressure. Same time इसकी direction जो है due to the Coriolis force it will get deflected. So ये instead of coming from southeast it will change direction to south. First of all it starts, you see that it is coming from south and then इसकी direction southwesterly. So the direction of this wind changes from south to southwesterly and that's why you see you get lot of rain here. This is the Indian coast. So first impact is here on the southern part of the India, Kerala side. अब ये जो wind है this blows with a tremendous force. Why? Because pressure gradient is too much. यही पढ़ा हमने winds का, isn't it? अब आपका pressure gradient है या 994 या 996 जो भी आपका low pressure center हुआ है, and here this is a high pressure 1024. See how much there is the pressure gradient 1020, 1024, 16. ये सारी wind जो हैं they create havoc in this Arabian Sea. So same way Africa, heavy rains in this east coast of Africa, and similarly now why rain? Because these winds are coming from the ocean, contain lot of water vapor, isn't it? So इनके अंदर तो they are fully laden. जैसे ही यहाँ पे rise हुई किया and touch the coast, heavy rain because moisture तो full है, relative humidity 100%. So yeah, you experience this heavy rain and slowly they keep moving. First they come to the southern part of India and then they start moving to north and even northeast. So northeast India also gets heavy rain due to these mountains. So ये रास्ते में इनके mountains आएंगे. So then again basically if you see in the Rajasthan side also, of course sometimes the mountains are in the same direction, but if the mountain is just 90-degree opposite, so if this wind start rising and we have seen as the wind rises temperature कम होगा, ड्यू पॉइंट एंड फर्दर कंडेंसेशन. चलो ठीक है, ब्रेक के बाद देखते हैं ये साउथ वेस्ट मानसून क्या क्रिएट करती है नॉर्थ ईस्ट मानसून. बिकॉज अगर आपने एक बार समझ लिया देन इट इज़ वेरी इजी टू आंसर दिस क्वेश्चन, बिकॉज ये क्वेश्चन भी राइट शॉर्ट नोट्स के पे आ जाता है. राइट शॉर्ट नोट्स ऑन मानसून regime इन इंडिया और वेस्ट मानसून और नॉर्थ ईस्ट मानसून. चलो ठीक है, ब्रेक ले लें चाय के लिए.
यस सर.
ओके,
थैंक यू सर.
Yeah, 12:45. This is thermal effects. The general circulation of winds of the globe is suppressed in these areas, and this intense cooling and extreme heating of this large land mass has the effect of producing a great anticyclone in summers, in winters, which is like the land which is getting in the winters the land is cool. So you see this high pressure here and the low pressure is situated in the what we call this centered in Mongolia, and depression in summers centered over Himalayas. So these two great pressure systems dominate the whole Asian region. In this two what we call the northeast monsoon of China and Indian Ocean and southwest monsoon of the Indian Ocean. If you see this northeast monsoons of China Ocean during northern winter, the Asian continent is cooled. Winter में of course the land is absolutely extremely cold and an intense high pressure area forms over eastern Siberia. पूरा land area है You have seen this near Asian continent, that near Siberia, you find that the maximum, the lowest temperature goes. So there you have this high pressure area situated in the Mongolia area over, and the wind circulating around this form the northeast monsoon. In the northern part of the China Sea, the pressure gradient is large. Winds likely 6 to 7. Why? Because high pressure and low pressure, when the pressure gradient is existing, so winds will definitely start blowing from high pressure to low pressure. And this northeast monsoon, what we call, it is again causing a good concern, and winds of course in this northeast monsoons are again as compared to southwest थोड़ा ज़्यादा है. Why? Because the wind direction plus the trade winds दोनों की direction same है, so they gets really modified or really amplified rather, that these northeast winds blow with a very furious, more strength. So Bengal and Arabian Sea winds are northeasterly force 3 to 4, whereas rainfall of the showery type is likely on the windward coast of China, and northeast monsoon becomes established in early December and continues until April. So this is due to the change in the sun, change in the heating pattern. So this is the pattern during your northeast monsoon, that you have a high pressure situated here, and definitely with the high pressure as compared to this area there is a low pressure. Here you see, and here again you have this low pressure, the wind starts blowing from high towards this low pressure of 1012. So you see this northeast, and again accompanied by the same pattern of the trades also. So they also bring lot of rain over Bay of Bengal, Arabian Sea not much, but Bay of Bengal, South China Sea. Now if you are passing these areas, so the weather is quite bad, and you see a lot of typhoons taking place even during this change of monsoon when you face this, and especially when you are going towards Japan. So you are heading basically in the northeast direction, and you straightway get a winds, swell, everything right ahead. So the ship speed gets definitely very severely affected by the effect of this northeast monsoon. And of course coming down, when you are coming from Japan towards Arabian or towards Indian Peninsula, so there you find the winds are helpful little bit from astern, and they do not create as much trouble as much while going towards Japan. The weather is very rough and the ships hardly move. So of course, as I told you today, you have better equipped, but otherwise even position fixing to know the position used to be a difficult job in the South China Sea during this monsoon, because overcast rain, heavy rain and overcast. So when we are dependent on the position by the what we call the stellar body, sun, moon, nothing is available. So difficult for the position fixing also used to be there. Now southwest monsoon, on the comparison, on the other hand, if you see, this is just the opposite, that during the northern summer this Asia continent is warmed and the high pressure over Siberia declines and is replaced by low pressure over northwest India. Now there is a pressure gradient between the high pressure and South Indian Ocean. That's what we have seen. यहाँ पे तो 996 है, there you have 1016, 1018. So there is a very steep pressure gradient between these two high and low pressure. So this causes this southeast trade to blow up to equator, and crossing the equator, the wind near African coast circulates around the low over Africa and brings rainfall to East Africa. Away from this coast, if you see this African coast, the wind is deflected to the right and blows from southwesterly direction. And in the Arabian Sea, the wind is southwest, force 7 to 8, and you know that monsoons, all the west coast of India, of course the sea is swell, very heavy winds, rain. So it is quite difficult, quite tough to come into the Indian ports. So a lot of delay also is there. Why? Because heavy rain, ships cannot work cargo. So a lot of waiting. So where you are going to wait? In the again outside open areas. So it is quite a troublesome time. In Bay of Bengal, southwest monsoons of force 6, 7 can be expected, and while in the southern parts of China Sea, of course, by the time these winds reach China Sea, the force reduces to 4 to 5. But on the west coast of India, the first impact of the southwestern is quite severe. Lot of rain, flooding takes place. The northern part of China Sea has light southeasterly winds, because by the time these winds die down, up to reaching into your Luzon Strait and all that. Now the air forming the southwest monsoon has traveled 1000 miles of ocean. So naturally when it is coming from ocean means it is saturated, lot of water vapor, and this results in heavy rain, especially near the coast. Definitely poor visibility, and it is southwest monsoon during June until beginning of October. So these are the few dates, and of course meteorologists, they can exactly predict, they have the radars, they can see. So normally 1st June or 3rd June is going to hit the Kerala coast. So these dates, you see how precise these things are, but weather is changing. Sometime monsoon is delayed, sometime it is little earlier. So ये तो हमने देख लिया साउथ ईस्ट एंड नॉर्थ ईस्ट आपकी monsoons, how they actually form and what all they create. So थोड़े से notes हैं, इसको अगर आप पढ़ लीजिए, so I think you can very easily answer. And orals में भी अगर पूछे, yes, so I think you should be able to answer what is this monsoons regime and how this monsoon winds take place. So there you feel, even very common in Bombay, that this land and sea breeze effect is very much prominent. So the regular alteration of land and sea breeze is a well-known feature of most tropical and subtropical coasts and large islands. So land and sea breeze hai kya? This occurs at time in temperate latitudes and fine weather in summer. Though they are much weaker and less marked as compared to case of lower latitudes. Now cause of these breezes, again unequal heating, solar, basically the solar energy. So now land and sea gets heated up unevenly, and by day the surface of land rapidly acquires heat from the sun, whereas the sea temperature remains virtually unaffected. So देखिए, every time same thing is prevailing. So it is already the effect of your solar energy, sun's radiation, which is creating all these effects. So even in the land and sea also, if you have seen, by day the surface of land, it starts getting the heat, starts getting heated up, and the air in contact will start rising, starts becoming cooler, and then low pressure getting created. So whereas the sea temperature is almost virtually unaffected. Why? Because there the heat, the whole mass of the water has to be heated due to the convection currents. So this case, if you see, as the land is heated during the daytime, the air over it will be heated by conduction, and this heating causes a decrease in density of air and the pressure falls. So low pressure will be created. Now imagine a coastal area where you have this land and you have the sea close by. So if there is a low pressure during the daytime, so what will happen? Gradient, pressure gradient exists. So the sea temperature remains more or less the same. The pressure is high as compared to the low pressure in the land. So naturally winds from sea starts blowing towards the land. So this pressure gradient is sufficient for air to flow from over to sea to the land. So this is called the sea breeze because it starts blowing from the sea towards the land. So normally you can see when the land is getting heated up right from the morning up to noon time or little bit after up to 2 o'clock, the land is getting warmed up by the sun's incoming radiation. So there will be a low pressure, and you see this sea breeze blowing it's not that strong, but of course it blows near the coastal areas. It happens after the sun sets, the land starts getting cooled. अब sea temperature तो वहीं पे है, वहाँ पे तो इतनी pressure changes हुई नहीं, and the air above also starts getting cooled, and जैसे air starts getting cooled, so it starts sinking and the high pressure is created. Now in the evenings, if you see past noon, you start seeing that there is a high pressure created on the land areas, whereas the sea, as comparison, the pressure over the sea is now low compared to that over the land. So you will find this pressure gradient and the wind starts blowing from land towards the sea. So this land breeze, generally very light compared to sea breeze, sets in shortly after sunset and continues until dawn. This is how basically your land and sea breeze affect the whole areas, especially the coastal areas. Now the sea breeze is usually setting late in the forenoon. That's when the sun has risen and starts heating up the land, and reach maximum strength about force. Occasionally they reach 5 or 6 around 1400. So that is the maximum time when the sun is it's heating the land to the maximum. So maximum low pressure will be around 1400 hours, and sometimes the sea breeze is of course quite strong for small ships, small fishing boats and all that. So land breezes are usually less marked and weaker than sea breezes. So sets in shortly after sunset and continues until the dawn. So this is what you have to be careful. Sometimes you are anchored near the coastal areas. It's not only in India, so anywhere where this land and sea breeze affects certain areas, this effect is quite pronounced, and it sometimes the ships start dragging anchor without realizing because the wind force is picked up 5 to 6. So effect of these breezes may be to deviate the prevailing wind, reinforce, neutralize or even reverse it. So this is basically your land and sea breeze, how they form. Now what are the factors? ठीक है, हमने ये तो समझा दिया अपने आंसर में कि land and sea breeze how they form due to unequal heating of the land and sea masses or the sea, the land mass and the sea surface. अब इनके और क्या क्या factors हैं which are responsible for creating these breezes? First, a dry desert coast as opposed to the forest or swamps. High ground near the coast, coastal areas में if you have a high ground, weak prevailing wind and clear or partly cloudy sky. So if you have all these conditions, then you see this land and sea breeze effect is very much pronounced. Cold current along the coast also has the effect. Now currents आपने पढ़े नहीं, but currents they do affect the climate of the coast. So when you study these currents also, you see how the climate of the coast according to the current which is flowing against the coast. So cold current in the coast also has the effect favoring the establishment of well-marked sea breezes. Small islands less than 5 to 10 miles in dia will not usually produce this land and sea breezes. So naturally you need a coastline little bit higher up coastline where this pressure distribution or low pressure high pressure sets in. Katabatic and anabatic wind. So katabatic anabatic winds pattern इनका भी almost same है. So it is again on to the topography और आपकी land की जो geography है उस पर भी depend करता है. So on clear nights the land surface gives off heat into space very quickly, resulting again in the cold layer of air near the land surface. If the ground is sloping, again mountainous, lot of areas are there where there are huge mountains near the coast. Now if the ground is sloping, the cold air at the land surface will be colder than the adjacent air over the sea. तो इसका effect क्या होगा? The air near the land surface being denser will start sliding down this hill due to the gravitational force, and this is the wind what we call the katabatic. Kata means down. So this down sliding wind from the mountain side due to the pressure difference, it starts coming towards the sea area and we call it katabatic. If the mountain is high, slope is steep, these winds can reach sea level with a wind force as much as Beaufort scale 7 in a very short time. So इसके लिए अगर there are a lot of areas where these high mountains are there and suddenly you find the wind picks up without any warning. So this is nothing, it is just a katabatic wind due to the sliding effect of this wind from the mountain comes down to the sea area. And because of their sudden onset, great force, they are of course dangerous to small crafts, vessels at anchor. If you suddenly get a wind force of 6-7 without any warning, without seeing any pressure change, so definitely these winds can damage these small ships or small crafts. Now, onset of this katabatic cannot be predicted as they have no relationship with isobars. That's why these winds are, again, you have no idea and suddenly they set in. So they are caused due to gravitational force and not by pressure gradient, because these winds are just sliding down the mountain. Anabatic just opposite, up. So during daytime land surface gets heated up, resulting in layer of warm air next to the land and inside a valley, and the air near the land surface is really warmer than the air above it. So if you just compare a mountain that down below is a valley and the upper surface high mountain, the relative colder air thereby displaces the warmer air out of the valley, sliding it up gently up the mountain side. So now here opposite happens, the wind starts sliding up. So this wind is called anabatic wind because top air is cooled and down below the air is relatively warm, and this warmer air starts going up. So these winds are much weaker as compared to the katabatic winds, having not much importance to mariners as they occur usually in the valleys. So katabatic जो है वो हमारे लिए थोड़ी सी important हो जाती है, that suddenly it comes down sliding and can create a havoc. ठीक है, तो ये तो आपकी various winds, various type of climatology, rest, sea swell, waves, I think we have covered. So you all are familiar with those terms, that what is sea, what is swell, and this much wind pattern अगर लेते हो तो आई थिंक इट इज इनफ. से इनसे बाहर कोई क्वेश्चन नहीं आएगा. सो क्वेश्चन कॉमन रहता है. एंड व्हाट यू कॉल लैंड एंड सी ब्रीजेस. So this is very helpful even if you see, if you are aware that when you are keeping a watch or coasting time mein, so you can see this effect very much pronounced and you can see how the winds are forming. So tha, yeah, I hope thoda bahut, I know little bit boring for you, but jaise jaise aapka interest banega, so if you can understand these winds, so paper mein bhi आंसर करना आसान हो जाता है. एंड फिर हाउ दी स्टॉर्म्स फॉर्मेशन, तो ये आपके बेसिक्स हैं. तो अगर आपने ये बेसिक समझ लिया कि यस, वेरी बेसिक इज हाउ द विंड स्टार्ट्स राइजिंग ड्यू टू द टेम्परेचर, लैंड गेटिंग वार्म्ड अप, एंड दीज आर द बेसिक थिंग्स विच गिव राइज टू योर स्टॉर्म्स. हाउ द स्टॉर्म्स, बैड वेदर, डिप्रेशंस start occurring, and even the flow of these winds from high pressure to low pressure in different oceans, different areas, how it is getting affected. So इसके साथ ये है कि yes, जब आप अपना पैसेज प्लान बनाते हो, so that time also it becomes useful because weather, so हम इसे चाहे weather routing कह लें चाहे कुछ भी है, so we always see that which all areas, which month, and इसके लिए best information आपके पास routing charts, isn't it? So routing charts, I don't know, I think most of you must have seen. Anybody who has not seen routing charts on the ship? आजकल ECDIS है, सारा कुछ ECDIS पे ही है. I hope you have seen the routing charts.
Yes, sir.
कुछ आइडिया क्या क्या इन्फॉर्मेशन होती है उस पे?
विंड रोजेस होते हैं तब बस
ट्रैफिक का भी होता
तब आपको पता लग जाएगा कि फिशिंग कहाँ पे होगी, जहाँ पे उन फिश को खाने को मिलेगा. Isn't it? There is something called upwelling currents. And ये जो पानी नीचे से, इसे कहते हैं upwelling currents. तो ये currents है, ये नीचे से nutrients को, lot of nutrients अपने साथ लेके आता है from कि कहाँ पे फिश है, कहाँ पे उसको खाने. There is so much of fishing off the Indian coast, right from India up to even up Karachi and all. So it is difficult to navigate, and you will see that you don't find even the passage. दिखता ही नहीं. बेसिकली आपको वेदर में मिल जाता है कि यस किस टाइप. दिस इज वेरी सिंपल. इन द समर द लैंड गेट्स हीटेड अप, एंड ये जो हमारा एशियन कॉन्टिनेंट है, यहाँ पे ऑफ कोर्स द नॉर्थ वेस्ट पार्ट, द नॉर्थ वेस्ट इंडिया, सो हियर बेसिकली it becomes a center of low pressure. Now this low pressure is quite low. Why it is created? Why it is getting created? Because of the heating. The land gets heated up during the summer, and you know, तभी कहते हैं. So जैसे वो start rise कर, so there is a tendency again what we call in meteorology के में हम क्या कहते हैं? Pressure gradient, isn't it? So there is a pressure gradient between high pressure and low pressure. यहाँ 996 है, यहाँ पे 1020, 1024. So there is a tendency for these winds. अब इस एरिया में if you see south of equator, what winds are prevailing? Southeast trade winds. So trade winds की direction क्या है? They are coming from southeast. So ये southeast trade winds जो है, whole mass they starts blowing towards the low pressure, because they will again natural tendency है from high pressure to low pressure, just to fill up this. तो ये winds जो हैं they start blowing towards this low pressure. And similarly इसके साथ ही अगर आप देखिए अफ्रीका कॉन्टिनेंट, वहाँ पे भी यही चीज़ है. सो अफ्रीका में भी ऑल्सो वी हैव अ डेजर्ट, वहाँ पे भी लैंड गेट्स हीटेड, इक्वली हीटेड अप लाइक इंडिया. तो वहाँ पे भी लो प्रेशर क्रिएट होता है. सो अगेन दीज विंड्स दे गो टुवर्ड्स दिस फ्रॉम हाई प्रेशर टू लो प्रेशर. तो यहाँ पे तो ये सीधी चली जाएंगी, बट जैसे ही so ये इट स्टार्ट्स बिकमिंग सदरली एंड देन स्लोली टू साउथ वेस्टर्ली. सो यहाँ तक इंडिया तक पहुँचते, दिस इज अगेन आई थिंक अबाउट 8-9 डिग्रीज लैटिट्यूड पे अब दीज विंड्स रीच. So and high to low pressure, plus ये winds आ कहाँ से रही हैं? Over the ocean, fully saturated with water vapor. Land में dry air है, यहाँ पे तो dry air थी. Summers में यहाँ पे जो dry air थी उसमें तो water vapor कम. But this wind is coming from over the ocean. It is traveling over the ocean and it is carrying lot of water vapor. And यहाँ पे जब coast पे आएगी, you have the mountains. It starts rising. So it starts rising. So again we have seen how the rainfall takes place. Cloud formation, and then these saturated हैं, water vapor तो बहुत ज़्यादा है इनमें. So जैसे this wind starts rising, it starts getting cooled below the dew point. So heavy rain. So rain भी है plus wind force भी है. Why? Because there is a steep water, this pressure gradient is existing. So इनकी जो force है, now you can see this Arabian Sea. This is the Arabian Sea part of the, ये आपकी Indian coast दिख रही है. So Arabian Sea or even Bay of Bengal, they will disturb the sea also, because जैसे ही wind force pick up की 7, 8, 9 force हुई, तो it will disturb, it will create big waves. So that's why this area during the southwest monsoons becomes dangerous. Ships तो चलते ही हैं. Have been coming, we have come many times in monsoon में. And imagine if you are coming from Japan side, तो आपका course भी जो है वो इस coast के parallel ही है. It's almost 90 degree to the wind and the swell. तो यहाँ पे थोड़ी सी आपको dog leg sailing करनी पड़ती है. You can't come straight. So sometimes you go away, then come like this, then go away, then come like this. So you have to avoid, because ships अगर 90 डिग्री पे आपका swell आ गया, beam swell आ गया, तो excessive rolling होगी. So this is how this monsoon is basically created. So normally you see this direction is south or south to southwest, ये direction आपकी आ जाती है. And they create heavy rain not only in the coast, over entire area. तो आप भी खुश हो जाते हो, नहीं बागी, अगर बारिश आए ज़्यादा आए तब भी प्रॉब्लम, अब तो ज़्यादा में. सो वी आर ऑल बेसिकली फुल, चारों तरफ कंस्ट्रक्शन है, नो ड्रेनेज, फ्लडिंग शुरू हो गया. नहीं, लॉट ऑफ टाइम दे शो, देखो जी घर में पानी चला गया. बॉम्बे वेरी कॉमन. बॉम्बे में अगर फ्लडिंग क्यों होती है? हैवी रेन,
रिवर नहीं है सर,
है
रिवर नहीं है वहाँ.
और कुछ हाई वाटर लो वाटर, इजंट इट?
Yes.
So that is the reason. एक तो ऊपर से हैवी रेन, बाहर जा जो पूरा शहर का पानी जो ड्रेन होना है, जो सी में जाना है, बाहर सी लेवल ऊपर. सो नेचुरली जब तक ये लो टाइड नहीं होगा, जब तक टाइड नीचे नहीं जाएगा, तब तक ये पानी ड्रेन ही नहीं हो सकता. तो यू विल फाइंड कि आपकी रोड्स, हाउसेस, एवरीथिंग इज फुल ऑफ वाटर. एंड ये वर्स्ट कब होगा? व्हेन देयर इज अ स्प्रिंग टाइड, मैक्सिमम टाइड, फुल मून हो गया, और उस दिन अगर जोर से बारिश हुई, सबके घर में पानी भी जाए. ओके, सो दिस इज हाउ बच्चे साउथ वेस्ट मानसून टेक्स प्लेस. एंड सेम थिंग इज द अपोजिट इज द नॉर्थ ईस्ट. नॉर्थ ईस्ट मानसून में क्या है? दिस इज अगेन द सॉर्ट ऑफ योर आइसोबैरिक पैटर्न. विंटर्स, विंटर में जो लैंड है इट स्टार्ट्स गेटिंग कोल्ड. सो ये सारा का सारा एशियन मास जो है ठंडा हो जाता है. सो जब कोल्ड होगा, सो ऑल द एयर विच इज बिकमिंग, जब लैंड ठंडी होगी तो हवा भी ठंडी हो जाएगी. ऑल दिस एयर स्टार्ट सिंकिंग डाउन बिलो. सो बेसिकली हाई प्रेशर इज क्रिएटेड. सो विंटर्स में हाउ द हाई प्रेशर इज क्रिएटेड, बिकॉज लैंड ठंडी है तो उसके साथ जो एयर इन कॉन्टैक्ट है वो भी ठंडी होगी. जब एयर ठंडी होगी तो इट स्टार्ट सिंकिंग बैक, इट डज नॉट स्टार्ट राइजिंग. सो इसके लिए ये आपका हाई प्रेशर क्रिएट हो गया. यहाँ पे हाई प्रेशर है एंड यहाँ पे आपका सी सरफेस जो है वैसे ही वार्म है. यहाँ पे एज कम्पेयर टू दिस प्रेशर इज, सो इसके साउथ चाइना सी में, बे ऑफ बंगाल. सो दिस इज बेसिकली योर मानसून रेजिम ऑफ द इंडियन ओशियन. अफ्रीका साइड जहाँ पे भी लैंड मास आया वहाँ पे कुछ ना कुछ, वेर एवर यू कैन अंडरस्टैंड नोट्स, जो भी आपको शॉर्ट अच्छे लगते हैं. वैसे तो इफ़ यू अंडरस्टैंड यू कैन राइट इन योर ओन लैंग्वेज, आप समझा सकते हो कैसे भी लिखो. तो प्लीज़ स्टार्ट प्रिपेयरिंग, मटेरियल इकट्ठा कीजिए, नोट्स बनाने शुरू कीजिए, चाहे बुक से, चाहे मेरे नोट से, कहीं से भी, जो भी आपको अच्छा लगता है. तो लिखने से एक तो नोट्स बन जाते हैं और थोड़ा सा याद भी हो जाता है. सो लास्ट मिनट में प्रॉब्लम नहीं आती कि आप क्या करें. तो थोड़ा सा पढ़ लीजिए. सो नेक्स्ट वी विल स्टार्ट विद द वेदर कोडिंग.